at the end of the part and we need to change the part. So what I normally do, I get this thing around about 0 degrees on the C-axis, the rotation axis, so that I can see this boss is facing upward. Because I want, well, let me back this up a little bit. I want to make sure that my tool is going between these jaws here, if you can see that. And so I really don't, I couldn't just rotate the part and set the C0 anywhere I want, but I don't do that because I want to make sure that tool doesn't hit the jaws. So what I normally do is set this around about 0. Doesn't have to be perfect at this point, just when I want to chuck on the part. But anyway, I'm going to jog it very close right there. I jogged it with the hand wheel down here. And then I'm going to back off the tail stock center and put the, well, first I got to take this plug out. It's drilling through the end of the part. It's drilling into the plug here. You can kind of see. And leaves a little teeny burr sometimes there. So anyway, I take the part out of the chuck here. First I got to back this jaw off a little further. Otherwise it won't come through the jaws here. I got to unchuck the part. I've got to open this up enough so that I can lift the part up like this. Now, it's usually coolant inside here. I've got to take this plug out of the other end. So I got to blow these jaws off. Make sure there's nothing on these steady jaws because we're going to be closing them down on the part. We don't want a shaving in there to dent the part. Next part, I put this plug in there, and I don't want to drill too many holes in these plugs, so I'm trying to sort of make sure that this hole where I put it is roundabout where it's being drilled. I suppose I could cut clearance in there. The reason I put a plug on this end of the part, you're probably thinking why bother, but these plugs fit kind of close. I'm chucking the part on here pretty hard with these jaws, even though they're pie jaws. I don't want to collapse the part because it's just a tubular shaped part. And well, before I do this, I get a little grease and put on these jaws. And a little bit on the OD of the part where it's being the steady rest, excuse me, is being run on here. Because these jaws are not roller jaws, of course. But back to what I was saying about this, when I'm chucking on the part quite hard, I don't want to be just depending on the tubular shape of the part. That'll come up against the jaws, the plug and everything, and it'll hold it a little better. So that's why I'm putting a plug at that end. So I want to chuck this so that I'm just eyeballing this right now to be up and down roughly, because I'm going to indicate that, and I'm going to chuck onto this, not with full chucking force yet. And I'm going to put this plug in here as well, trying to kind of keep these holes on that side. And we're going to engage the tail center again. This is going to help me adjust these jaws to the right place because they're backed off on the steady rest. But before I do that, I want to make sure my boss is straight up and down when I'm at 0 degrees on my C-axis here. So I'm going to indicate that actually with the dial indicator. I'm not going to rotate the C-axis to 0 it, because like I said before, I've got that situation of the jaws being relieved, and I don't want to hit my tools on the jaws, because I just rotated the C-axis to find my alignment, which is going to be on this boss right here. And I'm setting on Y0 here, center line of the part this direction, and now I want to kind of swing this indicator over the boss here. There's some coolant dripping off the spindle here. The reason I'm using such a, like a 1-inch travel indicator here is because I might have to move it quite a bit. I sort of get in a place where I know where I'm at here. I'm gonna back the indicator off. I come up on about 1 turn of the indicator. So I'm looking at this small needle being on the number 1. I'm going to kind of zero myself by swinging the spindle back and forth this way. And move a little bit forward in Z. Okay, now I jog it up. I don't know if you're going to be able to see this very well. Let's see. So right now I'm sort of zeroed at 100 thousandths into the travel of the indicator. I'm going to go up in X. Go around and back down. Now let me move you guys a little bit so you can see this better. Maybe right there. Maybe right there you can see it a little better. I'm going to pull this back as I jog it down because it looks like it's going to hit that indicator pretty much. See, it's not setting straight at all yet. I've got to move back about 100 thousandths. Or let's see, because we're on about 200. So I'm hitting the boss back here. This let me show you this boss back here. I'm hitting it with a dead blow hammer here on either side to rotate the part in the chuck. As I said earlier, I haven't got the part chucked that hard right now in the chuck. I'm looking at my indicator over here. I don't know, I'm going to guess right about there to start with. I'm going to push this back to my 100 thousandths so I kind of know where I'm at. Doesn't have to be perfect, but we're just getting it roughly there right now. See, that was, you can see it's not quite straight yet because when I go up and down the flat side, it's a little bit off. All right, pretty close though. We got to go half that amount. Back, I went a little bit too far. Re-zero there. Now this takes a little bit of time. You're kind of saying to yourself, why not just rotate the C-axis? And I could, if it was very close and my tool wouldn't hit the chuck jaw. I'm going up and down on the boss here to see where I'm at, kind of getting a middle of the range error there. I'm going to go back over here now and check it. It's not too bad. It's, of course, this is like a, this is, you know, this is a forging, so you can't get it perfect. I think I'm going to go with that right there. Let me check the other side again. I'm 1 revolution, 100 thousandths into the indicator. Got to make sure you're not like, I've done this before and been like a whole turn off. And not realized it until I checked it again. Okay, that's not bad. Now I'm going to go over here. I can get this camera situated. I'm going to go over here and I'm going to chuck onto the part a lot harder now. Now that's going to be good enough for our C axis setting, because we just want the holes to land in the center of this boss. This one's got a lot of material over here, of course, to be machined away, so it's not too critical. It's this center, it's this boss here that's critical. We want everything to run in center within a reason on that boss. But first I want to adjust these steady rest jaws so that they're up against the part. This is not going to be the final adjustment, but this is just going to be sort of the course adjustment, if you will. We'll bring them up to where they're in contact with the part. I'm going to indicate this a little better later, but I just want to get them on there so that when I take the tailstock away, part doesn't move in a chuck or something. All right, that's probably good enough for right now. I'm going to back off the tailstock. Take this plug out of there. What I'm going to do is indicate this steady rest to run true by adjusting the jaws, or the part to run true in the jaws, I should say. So I'm going to give me a 0 point right here on the top of the part to start with. I'm going to rotate around to the bottom of the part. You may not be able to see that very well. Maybe I can get a different location here. It's off a little bit. I'm going to adjust this, tension this up just a hair more. It's not very far off. Remember, I kind of pre-tension those jaws with the center on there, but they're not going to be exactly right. I don't know if you can see this on this side. I'll put it on this side so you can see better. It's slightly this side of 0. So I'm going to... Actually, I need to tension the back jaw. I don't want to make these jaws too tight. I just want to have them up against the part snug. Noticing a little bit of difference on the other side. Okay. That looks pretty good. Just want to get it, like I said, I don't want to get them too tight. And put the hammer probe in. And we're going to set the first, I'm using 4 different offsets on this part. And I'll show you why in a second, but I'm going to set the first one right on this face, this being G54. And I'm going to set my Z0 for G54 right there. And I'm going to touch off on the end of this boss. Now all the dimensions of this part come off of this boss here, from this face lengthwise on this part, actually both directions, but I'm setting the Z0 here because I'm doing something on the inside here, and that's the reason I'm doing it for this here. In fact, that's the only thing that's in relation to the G54 offset right at the moment. Later on in the part, there will be more things. But I want to set my Z's for these three. There's a fixture offset for this boss. So we got G54 for the end here and the overall part, other features. And then we got G55 for this boss, G56 for this one, and G57 for that one down here. And I'll explain that later in the video after the parts on the tail center here. That's when that comes more into play than right now, because no machine work is going to be done in here when the part's on the steady rest down this far. But on these two bosses, yes. So I'm going to jog this up to 0 here, and now I know that the face of that boss is at 4.385 in Z. So I want to set all my Z's for these three fixture offsets there. Although in reality I don't really need to absolutely worry about this one, G57, but I set it anyway just to be safe, because it'll actually change later when the tailstock is re-engaged to the part. It moves it slightly in Z because of the force of the tail center, and it's compressing whatever, the chuck jaws and the chuck and the spindle bearings and everything, and it moves the part slightly, you know, a few thousandths, 2 or 3 thousandths actually in the Z. I know where I'm going here, and I'm interested in this number, the 4.385 to the face here. These are all set in relation to Z0 being here, so I can just calculate from here back, because all the dimensions come from this boss anyway. I'm just going to set all three of these fixture offsets in relation to this 4.385. So I've zeroed my indicator on the face here, and then we're going to come over here to the work offset, and we already set G54 on the end of the part, so we're going to set this one G55. We're going to go teach 4.385, and then you just push the input key here. We got the number entered, and it should calculate this dimension here. Okay, so we're going to go over to this one and do the same thing. Teach 4.385 input, and teach 4.385 input. So all those numbers should be the same. So I can take this hammer probe out and we can start the program actually. holes. To boring those holes, they have to be, this is a pretty close tolerance. It has to be within plus or minus 4/10,000ths of an inch, or a total tolerance of less than 1,000th of an inch, if you will. And so we've got them in tolerance. I'll be measuring like 1/10 above the nominal dimension. If we look at this, I've got this stack of gauge blocks here, and the gauge is set up, this bore gauge is set up with this 0. You can see that right in the middle of the tolerance. Plus or minus 4/10,000ths on the actual tolerance itself. So be a couple of 1 or 2 tenths above the nominal, which is fine. This one's about the same. All the way down. You get down to the end of the hole here, if I can. Right there. It's about the same. So that looks good. Now we're up to the point of running those little 90-degree coolant driven heads. So we have to do some adjustments here to offsets before we run it, because the counter bores have to be kind of close. They have to be plus or minus 2/1000ths of being the same as each other on both sides of this boss here and of course this one. And if the bosses, the way they're turned, because they've already faced them to thickness in the lathe, so I don't really have any choice. I've got to land my counter bores in whatever is here, so I need to kind of stand off on the tolerance, on the offset, on the wear offset, and then run the tool and then make a adjustment and run it again on both of these counter bores, or there's 4 of them altogether, but the same tool is making all of them, and it's making the front ones with 1 offset and the back ones with another offset, and then these are on 2 different fixture offsets. So I run this one and this one, and I adjust my fixture offset. This is the reason I need the separate fixture offsets, because every one of these parts isn't turned identical, and I need to run both sides of the counter bore. Now I've already run it quite a few times, so I know that my offset gets it to the right thickness, because also it's like plus or minus 1/1000ths on the thickness after their counterboard, and a total of 1/1000ths on this one after the counterboards are in, but they have to be centered on these bosses within 2/1000ths of an inch. So that's where the sort of the trickiness comes into this setup here on this operation. So what I've done when I define, if we go over to the tool setup here, let's cursor down. I'm using these 2 offsets, 4D and 4E on the Mazak control. You can have many offsets on the same tool. You can see there's quite a few offsets on tool number 4, and use alphabetical letters kind of to tell the difference on the Mazatrol. And in the G code, you put like 4.01 for A, 4.02, 4.03, 4.04, and 4.05 are the tools I'm using here, if that kind of makes sense. But because this is set up like a general outside turning tool, they call it, I get these offsets down here, these wear offsets, and this is kind of, hit the wrong button. This is kind of ideal, because I can just use the particular Z offset wear. And what I'm going to do is I'm going to set these 15/1000ths plus on the front side, so that's 18.2 thousandths on that side. And on the back side, I'm going to set this, wait a minute. I gotta hit the right keys here on the control. I'm trying to watch this monitor on the video camera at the same time as I'm doing this kind of. So on the backside tool, I've got to move over here and set this offset minus 0.015 or 15 thousandths minus. So now we go back over here and we look at 18.2 plus on the front side and minus 18.2, if you can see these numbers. Let me go back here. That's the front and that's the back. Okay. I'm just toggling between the two offsets here on the control. So we're going to set them out 15 thousandths on the, again, here on the front, 15 thousandths that way, and on the back, 15 thousandths this way. And we're going to run the tool complete on both sides. Now I know everything else on this tool is running good, so I don't have to worry too much about that. I'm going to record it with the other GoPro camera here, but there's not going to be a whole heck of a lot to see here because of all the coolant. You might see a little bit, so I'll run the camera so you can see it. And I'm not going to record every single pass, but I got to make at least 2 passes on these on each counter bore to establish my fixture offset to begin with. And then the thickness, I know if I set that back to the original offset, the thickness will be there because it's been running very consistent on all of them. Now we got to do some measurements and make some adjustments to the offsets. First I want to just hit this with a very fine file to make sure there's no burrs. Because what I got to do is take this this dial depth gauge and I have to determine what the depth of my counterbores are in relation to each other. See, there's the way the drawing is dimensioned. It's not so much that there's any depth to these counterbores, they just have to be equal to each other within plus or minus 0.02 of an inch. I know it's kind of a strange way to dimension, but okay, so it so happens that these counterbores are like identical in depth to each other according to this depth gauge. See, that's 30 thousandths there, and it's 30 thousandths here. Oh, it's within less than a half a thousandth. So I'm not going to actually even worry about the depth or the centering on the offset. I'm going to leave it alone. It's just as likely that I'll make it worse rather than better if I start messing with that. That's pretty good right now. I'm happy with that. And we're exactly, let's see, I forgot the dimension is 2.240 to 2.242, the width on here, and we're right now setting it 2.270. well, a little bit less than 2.271. So I'm just going to go in my 15 thousandths on each tool and rerun it. I'm not going to record that because it's just the same as what you saw. And in fact, I'm going to do the same thing for this boss. And I'm not going to record the machining because you really can't see anything. This tool is kind of a little weird to run. It's you can't really hear anything or tell that it's cutting at all. Let me show you the counterbores. I guess it would be nice for you to actually see them right now, but they're 15 thousandths too shallow right at the moment on both sides of this boss. But I like to run each one of these separately and get them to depth rather than run this and then run this, because I have to make adjustments to the offset and I don't want to get confused on which one I'm adjusting. So I'm going to rerun, I'm going to set those offsets back in the 15 thousandths, and I'm going to rerun these two again. And then I'm going to do the same thing over here, set them back out, 15 thousandths on each one. You know, this one negative and that one positive, like I did before. And I'm going to run this tool and I'm going to mic the depth and the width and adjust it accordingly. Now this one actually has a closer tolerance on the thickness of the boss at the bottom of the counterbores, but the tolerance as far as the depth of the counterbores is the same, plus or minus 2 thousandths equal to each other. But as to the actual depth, it doesn't seem to matter according to the way they dimensioned it. This boss can actually be 15 thousandths difference in width. It's got a tolerance of 15 thousandths on the thickness, although the lathe guys held it very consistent, so it's making it easier for me to do it because they held this right on the nominal, and as well as this one too. So they actually helped me out here, but the location of these might vary a thousandth or so, a thousandth or two, and that could be enough to throw off the depth as being equal to each other. So that's why I have to kind of run one time out away and then run it in. Now, as far as the machining of this tool here, you know, the little angle head, I don't really precisely know what RPM that's running, so I'm being very careful with it. So I don't want to stall the tool because there's no real indication of how much power this tool is drawing. So I'm taking only 2 thousandths per side on the end mill. It's a 3mm end mill, if you remember from the previous videos, and I'm just running around here at 50 inches a minute, taking 2 thousandths per side, kind of a spiral cut going outward, and then I'm leaving like a couple of thousandths for the finish cut, and I'm taking a finish cut on the face that overlaps the tool 40%, just because it's only 2 thousandths deep, and then I'm taking a finish cut on the wall, actually 2 kind of spring passes on the wall, just to bring it out to size. Like I said, we're going to go to the tool data, the page down here. We're going to set this offset back in the minus 0.015, so that should be 3.2 thousandths. And then we're going to go over to this offset and set this one plus. This is the backside tool, which is what's in the spindle right now, if you'll notice, because it just did the backside. And we're going to go 15 thousandths plus on that input. So each one should be 3.2 thousandths. I've found that that's the sort of the magic number to get the width after that machines the counterbores. And like I said before, not to repeat myself too many times, but the depth of the counterbores, oddly enough, is not critical, but they want everything centered within 2 thousandths, plus or minus 2 thousandths on the centering at the bottom of the counterbores to the outside of the boss, for some, I'm not sure, reason. Let's check this after we've machined it. Already hit this faces with the file already. So we're 45 thousandths deep that side. And this side, I get on here, pretty much exactly 45 that side, so I'm happy with the depth. Let's measure the width and see where we're at. .240 and a half, maybe. A little bigger than that. 2.240.06. Okay, so that's good. That might be a, I don't know, about 4/10 under the nominal, but it's still in tolerance fine. So we're good there. So now I'm just going to run this. I got to adjust the offsets on that tool and just run the same thing on this boss. I'm not going to video record that because it's pretty much the same. And you saw that it's kind of difficult to get any kind of video of this tool running because of all the coolant and everything. And of course you can't run it without coolant if it's powered by coolant. I have to kind of get up in the machine to reach this. It's behind the part, so it's kind of a little tricky. Okay, looking at 47 thousandths depth there on that side. And if I could hold this steady. About 46 and a little bit more, about 46 and 2 or 3/10. So well within the plus or minus 2 thousandths on the depth. Let me get the micrometer, measure the thickness here. We're going for 915 to 916. I'm doing it kind of backwards this way so maybe you could see it. It's kind of hard to read the mic upside down, but I don't know if you could see that. So it's about 915 and a half, right in the middle of the tolerance. I knew that those offsets would cut a little bit deeper when I cut it the second time. That's been my experience with running it, so I didn't change them. Even though it seemed like it needed 1/1000th of an inch more, it really doesn't when you rerun it. Okay, so the only thing left on this first part of the operation on the tail stop, on the steady rest. I don't know why I want to keep calling this a tail stop. On the steady rest here is to run the drills on either side, the little drills that are also in the other two angle, the coolant powered angle heads. know you're asking yourself, and I was too when I'm editing this video, why not just probe it and be done with it? You know, the center line of the bosses, and I do have a spindle probe right here for the machine. It's not in there at the moment, and I have used it on this machine quite a bit. And over on the horizontal mill over here, my horizontal mill over there, I don't know if you can see it, it's behind the pallet rack. I do use the spindle probe quite a bit, and the parts are already machined and geometrically kind of straight when I probe them usually, except when in cases where it's not that critical. And on this setup though, I even started doing it that way. I printed out this and I showed the center lines of these two bosses, and I was going to probe the centers here. So this center line, and set the 0 back over here, and this center line, set the 0 for this back over here. And I might still do that. And it would make some interesting video content, I think, if I did. But in a way, I kind of like to see the actual indicator and the measurements, and set my offsets. And I'm running the tool twice to get it down to dimension. As far as the little angle head is what I'm speaking about right now, to get these counterbores down to the depths that I need. And it's taking 2 cuts, and I'm leaving, like you saw in the video, 15 thousandths, and taking it again. And it might not repeat the same. That kind of concerns me. I have to try that. But like I said, I like to kind of see what I'm doing with the indicators and measurements. And this spindle probe thing, I don't know. I'm just not really that comfortable with it, doing it this way. And then later in the video, you'll see that I'm setting the center line of this offset for these bosses, because this thing varies in location, the raw forging, where in relation to the turning. And so I need to do that for the cuts on the top of these ears on both sides. And that would be difficult to do with the spindle probe, as well as centering this. I can't do that and not rotate the C-axis. Now I could probe this and rotate the C-axis and get the 0 of my C by rotating and probing back and forth on this, but then I've got that case with the, as you saw earlier, with this relief in the jaws. And so you really can't, I mean, I guess you could tap the part around and probe it and tap it and probe it until you got it, but it's just easier to do that with a dial indicator, of course. So those are the couple of issues that I would have with probing, and I have to do it with indicators anyway. So I've got something working here, and I can't really afford to screw up any parts. It's not like because I work for myself, and if whatever I mess up, I pay for. So all of this lathe work and the forging and everything, if I scrap one of these parts, I would pay for it. And I can't really afford to go that route. So I've got something that I'm pretty confident in the way it's working, and I'm probably going to stick with it. Although I might make the probing thing just for the sake of making a video for it, maybe. That might be interesting video content, but I just want to address that now, because I know that I'm going to get comments on that. And as for the video itself, it's getting kind of long. I've already edited the first portion of this, and the indicating and setting up, and it's already getting to be like 42 minutes long before I even insert this clip I'm recording right at the moment. So I'm gonna have to split this into 2 videos, because otherwise I'm gonna have an hour and a half, almost an hour and 45 minutes long video with both operations, if you want to call that. The one here on the steady rest and the one with the tailstock. And so I think I'm going to split it into 2 videos, although it would be really one video split in half. And you can watch, I'll upload them both as the same, one after the other. But even uploading an hour and a half video, if you want to maintain decent resolution and everything on the video, takes quite a while. So in this case, thanks for watching this part of the video, but go watch the next part of it, because it's going to be just as interesting, I think, machining well, indicating the part in on the tailstock first, and then machining this boss and the other side of this boss and a few other features on this part. And I think that might be interesting as well to see the whole part. So thanks for watching this much, and go see the next part of the video.